and excellence in energy education. You know, we've got a few things in common. For one, I too was a part of a project that won a NEED award. I was a fifth grader then, almost 11 years ago at Fox Road Elementary School in Raleigh, North Carolina. Amy Schott was the lead teacher, and we wore these bright blue tie-dye shirts with words Energy Club written on the front in yellow text. Little did I know that my early involvement with NEED would open a plethora of doors and opportunities. See, in fifth grade, I wanted to be an astronaut. I loved astronomy, and I still do. I love looking at pictures of distant stars, planets, galaxies, and thinking about traveling there, even though it's not likely. And if you told fifth grade me that in 11 years, we'd be getting ready to apply to PhD programs in immunology, you'd probably have an unhappy and also slightly confused fifth grader. At an early age, I set out on a journey with a destination in mind. In middle school, I returned to NEED as a youth award staffer. This picture here is from 2013, my first year going into high school. And if you don't believe me, look really, really close at my name tag. I'm also wearing polar bear fish pins. See, we do have a few things in common. As I moved through middle school and on to high school, I was confident that I would be an engineer and help make renewable energy sources more efficient and cheaper to set up. The goal was to make this technology easy to integrate into third world nations who live without energy or without clean sources of energy, which might come back and affect their health. In the summer before my senior year of high school, I attended an engineering camp at MIT where I took renewable energy classes and created a project where we worked in teams to lay out the most efficient and cost-effective wind farm over a given plot of land using professional software. This experience motivated me to continue my journey to become an engineer. It felt like it was a giant step towards being able to provide power and empower often neglected and overlooked communities. The following year, I enrolled at the University of North Carolina at Chapel Hill as a chemistry major. In my first year, I was required to take an intro-level biology class. On the first day of class, I sat wondering how this class would ever be beneficial to me. I wanted to work with renewable and sustainable energy, remember? How could anything from this class possibly help me in my future? Little did I know. In that moment, I was closed-minded and unwilling to grow, but it didn't take long before my fascination in biology began. There was something about the way all the concepts built on each other, how each new item in itself was a puzzle piece, and slowly part of the picture began to form. At the end of that biology class, I had a pretty cool picture. I decided that I would switch majors to biochemistry to force myself to take more biology courses. After my second biology course, I had another pretty cool picture. The thing that I really liked, though, was that I didn't have two completely different pictures. Instead, the second picture was merely an extension of the first. But I already thought the first picture was a complete image on its own. And you mean to tell me that there was more? Well, how many pieces are there, and how do I get a more complete picture? These were all questions that were going through my head at the time. And at this point, I was hooked. My friends jokingly referred to me as a mobile professor, as I would often end up re-teaching our study group things from lecture. This love for a subject, this drive to learn, are two things I hope all of you can find. I won't tell you what you should find a passion in, or where to look. That has to be your own self-discovery. And my discovery began in that biology class, and I've enjoyed the journey ever since. I've done research in algae, some funky chemical synthesis research that wasn't for me. Last summer, I did breast cancer research where I looked at a behavior called autophagy, or cell self-eating. Cells will begin to eat themselves in order to reuse and recycle unused proteins and cell parts when they're in nutrition-deficient environments. And that's a pretty common characteristic of cancer cells. During the school year, I continued to conduct cancer research where I am looking at family of proteins which we think may have been mutated, and as a result, the mutated proteins tell the cancer cells to continue making energy via citric acid cycle, but we won't get into that today. Science as a whole, whether it has been my involvement with need or opportunities which have arisen from research, have taken me all across the nation. The red pins here are places that I have been to, and the purple pins are places that I plan on going later this year. The reason I told you this long, kind of scientific autobiography is to give you a glimpse as to what is possible for you, for your futures as scientists. I'm just a regular old boy from Raleigh, North Carolina, who enjoys astronomy, running, and dancing to new songs and old. But for you, you all succeed as scientists already, and in order for you to continue to succeed, you have to stay curious. Don't be afraid to ask why. And when you have asked a question that hasn't already been answered, it is your time to go out and answer it, as Madison did with her project, so congratulations. That is exactly what I've been doing and am doing now. I'll talk briefly about the work I'm doing this summer at the Broad Institute of MIT Harvard in Cambridge, Massachusetts. What if I told you that there are over 7.5 billion people in the world? What if I told you that there are approximately 5 times 10 to the 30th bacteria in the world? That's kind of like a billion, 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 times 1,000, and then times 5. I'm sorry if we lost a couple people there, but we're done with numbers for today. That is a biomass which exceeds the planets and animals on this earth. And many hundred years ago, a simple cut could have led to an infection. Amputations were often used to prevent the spread of the bacterial infection, but even then, the most common outcomes were death. That was the case then, until we discovered antibiotics. We use antibiotics to treat and prevent the spread of bacterial infections. We use antibiotics in food. And some of us are even guilty of taking antibiotics as soon as we feel symptoms of a cold. This overuse of antibiotics has led to a discovery of drug-resistant bacteria, also known as superbugs. There have already been cases of patients in the US who have died to these drug-resistant bugs because it takes researchers such a long time to discover and synthesize new antibiotics. The more drug-resistant these bugs get, the harder it will be to treat these infections. Essentially, we are at the verge of going back into the dark ages of medicine. But what if I told you there was still an organism that outnumbers the number of bacteria on Earth? What if I told you that humans are only the second deadliest organism on Earth, and this organism is the deadliest? What if I told you that we could use this organism, these natural killing machines, as an alternative for antibiotics? Well, then I would be talking to you about the bacteriophage, and what I think is the future of medicine. Bacteriophages, or phages for short, are a kind of virus that only targets bacteria, hijacking the cell's machinery in order to make more versions of itself and to infect more bacteria. So here I just have a simple diagram of how replication is going to work. So first the phage will attach to the bacteria. It'll insert its DNA into the cell. The DNA will replicate. Proteins that will eventually build the phage are made, they're assembled, and then they break the cell. And then you have more phage, which can infect more bacteria, and the cycle continues. There are protein markers on the cell membrane of bacteria that are not on human cells. So basically, we have an informal alliance with the phage. We both don't like bacteria. Because of the promising effects of phages, researchers have already been able to come up with phage cocktails to treat patients that have these antibiotic-resistant superbugs. And the results have been promising. In some of these cases, patients were cured. But not all bacteria is bad bacteria. Bacteria found in your intestines make up what is called your gut microbiome. The gut microbiome helps with host metabolism of nutrients, outcompetes some disease-causing bacteria, and helps with the development of the immune system of infants and younger children. People from all over the world have different looking microbiome compositions. It's a result of your environment and your diet. But researchers have identified a pattern in a certain demographic. Patients with a disease called inflammatory bowel disease, or IBD, tend to show similar changes in the type of bacteria present in their microbiome. We aren't completely sure why that is, but one of the leading hypotheses is that our friends the phage are showing up. Could they be to blame? And that's kind of where my research is falling this summer. We know that hydrogen peroxide, a random chemical that will not be found in your stomach, can induce phages. So I asked the question, how can chemicals that you eat induce phages? So I decided I was gonna pick some pretty common foods. So I'm gonna look at citric acid found in soda, acetic acid found in vinegar, iodine found in grain products in the US, and oxygen, because we all breathe oxygen, so why not? And if you take nothing else away from our time here, talking about little alien spider-looking things, then at least listen to this. You've already set out on your journey to becoming whatever it is you want to become. Being here today and this weekend is a huge step forward for you. The journey will be long, it'll be tiring, and full of unexpected turns and detours. But be resilient, be strong, and stay curious. And be accepting to change. As I changed from wanting to be an astronaut to an engineer to wanting to work to fight infectious diseases, find what makes you happy, as that is arguably the most important thing. I know this room is full of future engineers, chemists, biologists, lawyers, politicians, and maybe even the next president of the United States of America. We all have different destinations. Even Lil Nas X thinks his destination is at the end of an old town road, but at least he has a journey in mind. So make sure to enjoy, savor, and appreciate every moment that takes you there. Look around, learn from the people around you, sharing this moment. We are Need family, and if you ever would like to reach out for help or ask a question, I'd be happy to guide you. This summer at least, you'll know where to find me. Thank you.